Hello, my soon-to-be experts in writing equations in point-slope form. Let me highlight your expert group title. You guys are my pink group. So the title here, if you look at the top of your packet, is Expert Group Point-Slope Form. And the point-slope form of an equation is given right here. And here's what it says. Y minus y sub 1 equals m times the quantity x minus x sub 1. Okay, so you will become the experts in this form of a linear equation. So let's just read this information here at the top. Here's what you'll be learning. You're going to learn how to write the equation of a line given the graph of the line. Okay, so when given the graph of a line, how do you write the equation? And that's going to go actually down here with example 1. How do you write the equation given 2 points on the line? And that's going to go back here with example 2. And finally, how do you write the equation when you're given the slope of the line and a point on the line? And that right there is going to go with example 3. So those are the 3 things you're going to become an expert on. Now, important information. Let's take a look at these 3 items. The name point slope form for y minus y sub 1 equals m times the quantity x minus x sub 1 is not a coincidence. And that just means that this form right here is called point slope form for a very specific reason. Here's why. Look at the second arrow here. M stands for the slope or the rate of change of the line. Okay, so this M right here stands for the slope. So in the name, you see the word slope, and in the formula, you see M as the slope. Okay, and now my third bullet here, x sub 1, y sub 1, this ordered pair, is a point on the line. This is going to become another graphical clue. So when you see x sub 1 back here and y sub 1 right here, that goes with the point on the line. And so that's why it's called point slope form, because visually, when a graph is in this form, you can see a point and a slope. So point slope, point slope, point slope. Okay, here's example 1. Example 1 says, write the equation of the line graph below in, here it is, point slope form. So the first thing I want you to do is recopy point slope form. Bring this down. We're going to click and drag this formula down. So here's what you're going to write. Y minus y sub 1 is equal to m times the quantity x minus x sub 1. Now, when you're teaching this, when you're the expert and you're in your small group and you're actually teaching this to your peers, you're just going to have to straight up tell them, guys, you have to memorize this. They're just going to have to memorize that point slope. Here it is. Now, what you're going to do is take your graph and find the key items that you need here. Now, you need to tell your students there are only 3 things that you're actually going to fill in place of some of the variables here. The first one is, yes, you're going to have to fill in the slope that goes with your line. So why don't we go ahead and grab that first? We've been working on slope. You guys know how to find slope. And since this is just graphed for you, why don't we just do the easy way to find slope? Let's just count the, the rise or the vertical change here in y and divide it by the horizontal change in x. Okay, so by counting the slope, it looks like I'm just going up 1. So I'm rising 1 and I'm running. I apologize because the graph is a little faint here in color, but I'll do my best here. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This distance here, the run, looks like 10. So I'm going to say that my slope is, I'm changing 1 on the y for every 10 on the x. So what I'm going to do is plug that in for m. So I'm going to have y minus y sub 1 is equal to 1 over 10 times x minus x sub 1. Okay? Now, the next two things that I'm going to plug in are, I'm going to plug in numbers for the y sub 1 and the x sub 1. Okay? Not for the regular old x and y. They stay x and y. Just these two, the x sub 1, y sub 1, is going to represent any point on my line. Now, if I go off of what we've been studying, it might be easiest when you're teaching this to tell everybody, like, look, see this point here that's marked, the -6, -2? Let's call that point the x sub 1, y sub 1. And when we were learning slope, we would have called the next point over here to the right, we would have called that x sub 2, y sub 2. Now, it truly doesn't matter which point you use, but for consistency, why don't we go ahead and just use this one, because it would have been marked for us as x sub 1, y sub 1 anyway. Okay, so let's write down, so x sub 1 is hooked up with the number -6, and y sub 1 is hooked up with the number -2. Okay? So bringing those values and plugging them back here, this is what we're going to have. Bringing this down, y minus, now, y sub 1. You know, when we plug a number in for a variable, we like to put it in parentheses, and that's what I'm going to do. So y minus, here it is, -2, equals 1/10, remember that's the slope, times x minus, and now here comes x sub 1 right here, -6. So that is point slope form. And again, what that shows me, if I was looking at this equation and I didn't have this picture, I would know that the slope of my line was 1 over 10, and I would know that my line went through the point -6, -2. See, it shows a point and a slope. Point slope. Now, most mathematicians will actually go one step further with this. Since negative times negative makes positive, we could write this as y plus 2 is equal to 1/10 times x plus 6. And again, that's just because the negative, the double negative. But here's the deal. Because you can see it this way, you have to be smart enough. Like when we get into graphing, when I give you this and I make you do the graph, you'll have to be smart enough to realize that these pluses used to be minuses, and the point itself had the opposite signs. Like, so if you see x plus 6, you know the point on your line, the x value, is the opposite of that. And when you see y plus 2, you know that the y sub 1 is the opposite of that, -2. Okay? So that's your first problem in point slope form. Now, my last thing before we leave this example. Students will say to me, Ms. Callahan, well, you plugged something in for these 3 highlighted values. Why didn't you plug anything in for the x and the y? Like, why does y stay y and x stay x? And that's a great question. And the reason is you have to be able to fill values in for x to get out values of y. See, they're in a relationship. And as x changes, it will affect what y is. So this is what allows us to go to different points on the line. Let me give you a quick example. So say that I just made like a little table here. Well, supposedly the point 4, -1 is on my line. 4, -1, because it's right there on the line. So when x is 4, the y value should be -1. Well, let's see if it is. let's let the x value be 4. So let's do y plus 2 is equal to 1 over 10 times, here we go, 4 is going in for x, 4 plus 6. Okay, let's keep solving. Y plus 2 equals 1/10 times, well, 4 plus 6 is 10. Keep going. Y plus 2 equals, well, 1/10 of 10, you can either put that in your calculator or just cross these 10s out and you're left with the number 1. And to solve for y, you subtract 2 from both sides and you get y equals -1. And see, boom, there it is. So when x was 4, the effect on y is that y became -1. And do you realize that you can keep doing this? I mean, you could go to 14. You could let x be 14. If you come up here, okay, to your answer for your equation, and you let x be 14, let me do this. So say this was a 14 plus 6. Well, 14 plus 6 is 20. 20. And 1/10 times 20 is 2. And then if you subtract 2 from both sides, your y will be 0. See how it's different? So when x was 14, y was 0. And that just means that way down the line. So if I kept going on with my graph, here I go to 10, so 11, 12, 13, 14. See, I'm right here. And the line would continue. So I have to let x be open for business, which is going to allow y to be open for business. And this is what creates the mobility to go to different points and locations on my line. Okay, so every equation of every line is always going to have an x in it and always going to have a y in it. Okay, so let's go to example 2. Almost done. Example 2 says, write the equation of the line that passes through the points, and then they give me 2 points, in point slope form. So let's start with point slope form. Let's write down what we've memorized. Y minus y sub 1 equals m times x minus x sub 1. Now, we know there's 3 things we got to fill in. We got to fill in m. So let's start there. We know how to find slope given 2 points. We're experts on this already. So let's call the first point x comma y. And let's call the second point x comma y. And this will be the first set. And this will be the second set. Okay, let's sing our slope song. You ready? You may think it's strange, but it's just the rate of change known as slope. And m is really dope. It's the rise over run, y2 minus y1 over x2 minus x1. Cha-cha-cha. Okay, so there's a little review for that. Gonna get that slope here. So let's set it up like we do. We draw our fraction bar. Minus, minus. These are straight from the formula. 4 sets of parentheses. And we start to fill in our numbers. So y sub 2 is, carried up here, 4. Y sub 1 over here is 3. X sub 2 is 4. X sub 1 is 2. So m will equal 4 minus 3 is 1 over 4 minus 2 is 2. So our slope is a half. So let's click and drag that up into our formula and put it in for m. So y minus y sub 1 equals 1/2 times x minus x sub 1. Beauty. Okay, last part. We got to fill in our numbers for y sub 1 and x sub 1. Okay, so let's use right here x sub 1, y sub 1. Let's use 2, 3. I want to make a point. You could use 4, 4. Even though this is x sub 2, y sub 2, it will still work if you use it. I just tend to go back to the one that's actually marked x sub 1, y sub 1. But say it was multiple choice. Say this question was in multiple choice format and one of the answers, this answer wasn't there. You'd have to look to see if this answer was. So y minus 4 equals 1/2 times the quantity x minus 4 is also an acceptable answer, but I'm going to use 2, 3. So here I go. Y minus y sub 1 is 3 equals 1/2 times x minus 2. Beautiful. So what can I tell from this? Well, this gives me a lot of graphical information. This tells me that I have a line whose slope is 1/2 and whose graph goes through the point, ready for it, 2, 3, x, y. The one behind the x is the x, the one behind the y is the y, and if I would even just enclose these into parentheses, you can see that the point is just a positive 2 and a positive 3, boom. Again, it's almost like you just take the opposite of the sign. The minus is built into the formula, so 2, 3, 2, 3. And that's the answer. Okay, last but not least, write the equation of the line with slope negative 6/5 that passes through the point 3, negative 2. Oh no, typo. Not in slope-intercept form. No, 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 no. Tell your students when you teach this, that's supposed to say point slope. My fault. Cross it off, point slope form. So let's write down point slope form. Y minus y sub 1 equals m times the quantity x minus x sub 1. Okay, so let's grab the slope. Slope is the first thing I've got to fill in. Well, guess what? They gave me the slope. See, up here, I had to work for it. Here, they just handed it to me on a silver platter, so let's go with it. So y minus y sub 1 equals negative 6/5 times x minus x sub 1. Beautiful. Now, I just need to fill in my point. Y sub 1 and x sub 1. So let's go to the point right here. Right here. 3 will be my x sub 1. Negative 2 will be my y sub 1. And I just roll with it. So here I go. Y minus. Now I'm plugging in negative 2. So I'm going to encase that in parentheses. Equals negative 6/5 times x minus 3. Okay, now you could leave it like that because in this form, I can see that my line has a slope here of negative 6/5 and it passes through the point positive 3, negative 2. Now, sometimes we go on, double negative, that becomes positive, and then here, this just stays negative because there's not a double. Okay, so this would be the final answer. Now again, when we go to graph these guys, I can't stress this enough. What we would do, this is a sneak peek of a future lesson. See, what we would do is we would grab the point, and you have to know the point is the opposite sign of what's behind your x and y. So like you see how it's minus 3 here? Well, we would know it was positive 3. And see how it's positive 2? Well, we would write negative 2. And see how that matches the actual point, 3, negative 2? So we would go 1, 2, 3 on the x, negative 2 on the y. We would start there. And from there, our slope would take us down 6 on the y. 1, 2, 3, 4, 5, 6. And right on the x, 5. 1, 2, 3, 4, 5. So it would put us down here and see we can graph. So it's really important in point slope that you can pick out the point and the slope. Okay, awesome. So you now have all the makings and ammunition here to become an expert and to teach your peers all about point slope form. In order to do that, though, I'm going to request that you finish the mastery and get it checked so you're not doing anything wrong yourself. So there are 15 mastery questions waiting for you to complete here. And then when you have that complete and graded, then we're